Hi everyone. For this lab right here, we're going to be working on getting the data, the actual data of the sunspot, the annual sunspot, and we're going to calculate the average sunspot cycle. So what you're going to do is that you're going to just follow and repeat the step right here. I'm going to scroll the video down slowly later on. So if you cannot follow it or a little bit behind, you can pause and type in the step. But in Canvas, I also put the first, this one right here, the code for the first cell, and this one right here, the first line for the second cell, right? So you can copy and paste that over. So as you can see right here, this is a website that I go to get the sunspot cycle annually. I also provide this link in Canvas, so you can click on that and see them for yourself. Now, this first cell right here is to import the library necessary to do the work. And the Panda is to getting data to do analysis. We used this before. The Numpy package or library is for us to later on use it to calculate the mean and standard deviation. And the Bokeh is another plotting library from Python. This one right here I like because you can do some interactive functionality with the Bokeh. Like for example, if you scroll your mouse over a point, it can give you the XY coordinate. So this way right here, we can use it to find out what year and what sunspot, what the number of sunspot for that year right there. So make sure that on your first line, you have this all of this the library imported. Okay. The second line is to download data into a Panda data frame right here. Right. So as a CSV file. So we're going to read that from this website right here, the URL. And you can see that the delimiter is a semicolon. If you open the CSV file, you see that. And also because the data doesn't have a header, right? So we have to give it the header 1, 2, 3, 4, 5. In the CSV Excel CSV file, there's 5 columns. So the first one is year, and the second one is sunspot. The last 3 columns we don't need that, so that's why I just named it a generic column 3, 4, and 5. Now this one right here, you can see that I'm just doing the header, using the head function of data frame to print out the first few lines to see how it looks. You can see right here, right? It started the year 1700, and the number of sunspot is about 8.3. 1703, there's 38. Yeah, wow, that's a lot. Number of sunspot right there. Okay. Now I also do the tail, tail right here to look at the tail end of the data and see how it looks. If you take a look at that right there, right, the data go as late as the last year, 2019. We were at the minimum. Notice that the number of sunspot for the year 2019 was only 3 or 4 right there. I mean, compared to, like, for example, 38 and 1703, right? And when there's more sunspot, there's more solar activities, and it can influence the weather on Earth. For example, make it a bit warmer when there's more sunspot cycle, or make it cooler for the number if you have less number of sunspot cycle right here. One thing about the data is that it has a year 1700.5, right? And that's not going to look good for our plot. So what I do is that I just extract the year column out from our general data, and I put it into a temp right here, right? And what I would do right here is that I'll take that, whatever year it is, like for example 2015, I minus 0.5, so make it 2015 even. And then this one right here, I converted integers, because year is an integer 2017. For example, 2020 is not a real floating number. And you can see right here, well, when I print out year, it has integer like this. The next one I did was that I also extracted the sunspot column and put it in a temporary variable sunspot right here. So we could plot year versus sunspot in the Bokeh. Okay, and then the next step is give me 1 second right here. Okay, so this is the step that we are using to plot for the sunspot right here. So make sure that when you get to watch this video right here, right, just pause the video and take a look at this cell right here and type it in like this right here. I mean, I have colors navy, for example, right here, right? If you want, you can change it a little bit. You can, for example, make the size a bit bigger or smaller. And then, for example, you can change it to instead of a dot right here, right? You can change it to an X or something, but I find that the dot would work in the situation right here. So if you want, you can change the color. You can make the size bigger or smaller a little bit right here. And this one right here is for transparency. I just set it 2.5 right there. And then this slide right here, it would be to output the notebook and show it right there. Okay, so basically this code right here is to plot the number of sunspots using Bokeh. So if you want, you can pause the video right here and just copy the code. Now here is the output to, here's the output right here. Let me reset it. So this is how you probably gonna see it when you first plot it right here, right? You see that it gives you the title, it gives you a number of sunspot, and we get it from here. We set it right here, title, year, number of sunspot, that. And the one nice thing about Bokeh is that it has tool right here that you can use to extract data interactively. Like for example, if I want to take a look at this point right here, right? If I mouse over it, it would give me the year, 1723, and the number of sunspot is about 202. See right there, right? And we set it. We set the two tips right here. This is the line that does a hover and the two tip what show on the two tip right there, sunspot and year right there. Okay. So like for example, if you go over here, 1837, and that's the number of sunspot. What we're gonna do in this lab is that we want to look for the maximum, the local maximum, right? And the next local maximum, and we're gonna calculate the year in between right there. So that's that's just one cycle. So from one maximum to the other maximum. And the one neat thing about this Bokeh is that you can see that there's a zoom tool right here, right? There's a box zoom. So if you click on that, okay, and then you drag it. Give me 1 second. Let me click on the tool right here, and I drag it like this. Let's say right here, right? And it would jump in, zoom in, so that you can see it a bit better. So let me reset that and try it again right there, right? So if I drag it like this, for example, it will zoom in and it would give me a closer look. And of course, right, you can also use the pan tool to move it to the next period or move back to the previous period. So the way that we find the number of sunspot cycle is that we look at, like for example, right, you see right here, right, there's a peak in the valley, there's a peak and there's a valley, there's a peak in the valley, right? So you want to go for the first peak, which is the year 1705. See right there, right? 1705, and the next peak is 1717. So 1717 to 1705 is about 12 years. So what you're going to do is that you're going to make a list of sunspot cycle, and then you're going to put 12 right here for the first, from 1705 to 1717, right? Then the next one is from 1717 to 1727, right? So that would be, let me see, 1717 to 1727. So that would be 10 years. So you go here and you put down 10 right there. See, 1717, and then 1727, right? So the next one is, you see that it's going to go down. So let's go up, down, up, down, up right here, right? 27, and the minimum right here is 33, right? And then the next one is going to be 38, right? 38 to 27 is 11, right? So you put 11 right there. And then when you have, you're going to do it all the way from 17 to the present, which is the latest data, which is the 2019. Find out the cycle. And then you're going to put all of those things into a list. When you have it into a list right there, right, you can use Numpy and the mean function to the mean function right here to calculate the average of sunspot cycle and the standard deviation. The standard deviation is just telling you how spread out your data is right there, right? And if I execute this right here, for example, I'm just going to do the first three, right? You see that it's going to give me the sunspot cycle is about 11 years, and the standard deviation is about 0.8 of a year, right? Which means that it's going to be 11, and then it could be, and then the other data is going to be somewhere between 11 minus 0.8 and 11 plus 0.8 right there. So again, right, for this lab right here, just follow the procedure that I have in this video. This is the first cell, okay? Let's see, let me run this. This is the first cell. This is the second cell, okay? And then this one right here is just to take a look and see if the data is okay. This one right here is just convert it into an integer and get rid of a decimal 0.5 right here, so it looks better. This one right here is to extract the number of sunspot right here. Okay, this one right here is where you kind of plot that. So basically, just go back and forth in the video and copy this code down. And once you have this, when you have this graph right here, you can zoom in and zoom out. You can pan it interactively. Let me see. You can reset right here. Right? Here's the reset, so that you can reset it to the original figure, and then you can also save it. You can also save it right there if you want to save your diagram. And this one right here is a wheel zoom. I don't use it a lot, but if you want, you can see right here, right? I use it, and that's a wheel. I'm just using my scroll wheel to zoom in and zoom out. Okay, so right. If you have any question, feel free to ask me. Make sure that I also have some other question in Canvas. Like for example, I'm going to ask you to figure out which year has a minimum and maximum of sunspot for the last 50 or 60 years, and how many sunspot is happened within the last 50 or 60 years, for example, right there. All right. So good luck. If you have any question, feel free to ask me.